AI is no longer the nice to have.
We're living in an exponential world.
That content creation is going to be IP protection.
I'm grateful.
This is the Pete Sacco Podcast, where technology meets consciousness. I'm Pete Sacco, entrepreneur, technologist, and modern-day mystic. Each week, we explore insights that expand our minds, challenge norms, and move us towards a more intelligent, intentional future. Each episode, we explore the edge of what's possible in business, in tech, and in human potential. Let's dive in. Hi, everyone. Thanks for joining me here, Pete Sacco at the Data Center Edge with my podcast guest here today is David Quirk, CEO of DLB Associates. David, good to see you again. I hope you're well.
Likewise, same for you.
I appreciate you being one of the inaugural guests here on the Data Center Edge. And, maybe I'll start with the quick story of I knew your predecessor for a very long time in the data center here, Don Beatty. As being the guy who was building all the Google data centers. And I know you were there for a long time, but, you've come on as the CEO for years now, and you have a long 25-year history in the data center and ASHRAE leadership. And now you've got a 500 person plus consultancy. And looking back, what are some of why don't you give me a brief history, but what are some of the lessons that you've learned as you've transitioned from, in time at DLB?
Yeah, great. Thanks again for having me. And I love the fact that I'm the first. That's the one thing we are good at, is being first at a lot of things, helping solve first of a kind problems. So for me personally, I start off as a mechanical engineer. I've got over 25 years in the industry. I've worked for a number of different companies, 3 Fortune 100s, 3 consulting firms, and a startup over that course of time. I have been in the built environment my entire career, have helped work on and solve a lot of different types of projects, from small retail to commercial to higher ed to power plants to telecom and data centers. And I've spent the lion's share of my career in the mission critical space. So whether it was utility, power plants, be it single or combined cycle, recips or coal-fired power plants, or the telecom and data center space. I've just always thrived working for the mission-critical space where, high availability is paramount.
Well, we thought we were going to be the cool kids again, right? I mean, for a while it was got pretty complacent, but now all of a sudden it's cool to be us again.
That's right. We plateaued for many years there in the cloud space, where we thought, nothing's ever going to change. Some of us knew otherwise, and to that point, so DLB, just adding on to the history that you mentioned there with Don, he helped co-found ASHRAE TC99 for mission critical facilities and data centers. That was back in roughly 2004. Through the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And that technical committee is really what's laid a lot of the foundation for the data center industry today. They've published, 14 books, tons of articles and white papers and technical bulletins. And most notably, in the beginning, they got, he co-founded it with a gentleman named Roger Schmidt out of IBM.
Yep.
And what was the catalyst was this new thing called a blade server.
Right.
And nobody knew how to deal with this high density of this new thing they were going to dump into the data centers. So fast forward, here we are again. Yeah. History repeats itself. And so really it was about establishing a boundary condition that all the IT OEMs could agree upon for how we manage that interface within the data center. So you put that cabinet in there. Okay, how does the environment around it need to be designed and managed and operated to make that work properly? No matter who the manufacturer was that was inside that box. And that's the really important part. So they published the thermal guidelines. Yep. And that set the foundation for this platform interface that we've all worked against for the longest time.
Yeah.
Until just recently here, when we got this new type of chip architecture that requires a different cooling medium, aka some form of liquid, to make it work.
So
So
before we get there, because that's where we're
yeah,
going, we all know that, right? That's what everybody's waiting for us to talk about is what the future of AI data centers are going to look like. Why don't you tell me a little bit about DLB Associates and, what
sure.
do we want people to know about the company's mission and the way you approach solving the challenges, different from your predecessor, right? Because it's your ship to steer now. And so why don't you give me a little bit about what DLB is doing for the world?
Yeah, starting with our mission statement, it's to empower innovation and transformative change in the built environment. It's a real simple, broad mission statement, but the key words there is innovation and transformative. So I'll call it underlying mission since the beginning of time. The company's 45 years old now. Has been how do we innovate and disrupt what's already the usual norms? Because there's always a way to do something better.
Right.
And that has always been the underlying driving force of the company. So we are an MEP engineering company at its core. We provide end-to-end services. So be it programmatic help on the front end, like test fits and prototypes for different building types, namely data centers these days, but we are in a couple of other markets as well. Professional engineering. We've done projects here throughout the U.S. We're licensed in 49 states, but we've also worked elsewhere in the world. In fact, over 30 countries around the world over the last 45 years. And we also do building commissioning. So think the ASHRAE level, L1 through L5, even though that does go 0 to 6. And we have a construction quality management group. So we do owner rep, project management, outsourcing, QA/QC. Just think of all the elements that help make sure the execution of the project's done right. And then last but not least, we have an energy management group. So we help both the supply side and demand side once buildings are in operation or they're trying to figure out, hey, are we doing the proper sub-metering on the PUE side of things, et cetera. We step in to help support all that.
And who's typically been the type of customer that you're servicing and the size and scale of the project that you guys are doing most of right now?
Oh, we serve the whole spectrum of options. So we are dealing with gigawatt plus campuses currently and working with several of the hyperscalers all the way down to, I'll call them mom and pop developers that are maybe doing a 5 megawatt or less size of a site. Of course, what you and I call a small versus big data center recently went under a major revamp. But, even smaller than that. So we're pretty much supporting the whole spectrum of the customers that are in the space right now, as well as some enterprise. There's still some out there that are keeping some on-prem presence and refuse to have jumped all in on the cloud. And so, a little bit of all of those. So we have a nice wide cross spectrum of visibility.
And I am sure you, like me, are being confronted with everybody wants to be in the data center game today, right? There's the people who have been in the data center game for a long time who know what they're doing. And then, yesterday a guy was working at a Dunkin' Donuts. Now all of a sudden he wants to be a data center operator. So we're seeing a lot of that. But let's set that aside for a second and let's talk about the era that we're in right now. Because I like to say that, AI, for as sophisticated as the data center industry has been, AI caught the data center industry napping. And all of a sudden now everything that was not allowed is suddenly standard. Keep water out of the data center. Nope, it's the only way we're going to do it now, right? Densities are never going to go beyond a certain level. And now we're confronted with 100 and 200 kilowatt racks. And heck, you and I just saw NVIDIA talk at Data Center World. And, he's talking about 500 kilowatt racks and 5 megawatt pods. So we're in that era of, direct liquid to chip cooling. It's no longer hypothetical. You guys, more than anybody, have been at the forefront of what that means. Why don't you give the listeners a kind of your interpretation of where the industry came into play, where you think it is now, who maybe even some of the people that you think are doing a good job in that space, and where do you think it's going to go?
Sure. Well, it all started probably back in 2007 timeframe for myself. Maybe it was 2008. It's a long time ago, but I was an industry advisor on the National Science Foundation's IUCRC ES2 program. And this was basically an energy efficiency program for data centers. But at the time, it was focused on how do we put together these new things called a cold plate on top of a higher density chip. And so it was a consortium put together by the National Science Foundation that included 5 different universities, as well as about a dozen industry organizations, large enterprises, that included the likes of the IBMs and the Dells of the world, et cetera. And the goal was to try and fuel the innovation and the new technology that was going to be necessary to solve this new problem that we all knew was coming, meaning we were going to have to shift to forms of liquid to cool these higher density chips. So it's been on the roadmap for the industry for a long time. Nothing new, right? Liquid cooled mainframes go way back.
Way back.
So there was definitely, a couple of decades in the making here. So we had that working in the background. We had the AI trends working in the background. So Google's DeepMind, was coming out and had lots of public articles talking about how, it was beating the best players in the world at chess and then at Go, and then multiple people at all those games at the same time. And so we knew the capability of AI was there, but everybody was afraid. Don't let, Pandora's box open, right? So it was kind of stowed away as, hey, it's a great academic tool. It was great to see that this thing could be really smart, but we didn't feel the industry was ready for it. Well, in the background, NVIDIA had been working and greatly excelling on the development of their GPU, or graphic processor unit. And it's really fascinating. So there was an interview back in 2009, I believe, with Jensen, where he talked about the difference between the power of a CPU versus a GPU. And a CPU is basically the embodiment of text translation, really good at doing that. But a GPU is really good at doing photo and video translation. And so it was really kind of the culmination of new companies forming, like OpenAI, that had developed, taken some of what Google had done and others and put it into a new form factor. What NVIDIA had done for the GPU space, what had been developed in the background by the academia and the government entities like the National Science Foundation for the underlying hardware to support all of this. And just kind of, I'll say it, the post-pandemic divergence in, hey, what are the rules anymore, right? Let's try all this new stuff. Let's do things that we had never done before, like us as an example, saying we were going to go 100% virtual. Right. Nobody would have thought to try and do that as a consulting company pre-pandemic, right? So I think
that's right.
Yeah, the perfect storm and convergence of all those things all at once to form the ChatGPT moment, right? For the lack of a better word or point in time. And that flipped open Pandora's box, and here we are. And so now there's, I was on a podcast recently, we were talking about 1 megawatt racks.
Yeah.
1 megawatt racks. Okay, how are we going to support that? So it's funny how most of the industry, we're still trying to figure out how to support the 100 kilowatt rack.
Yeah.
And really get it at scale in the deployments. But there's many, many projects in flight with all that happening nowadays.
Yeah, if you take a look at a profile of the, few thousand data centers that are predominant in the United States, just stick in the United States, the oldest data center market in the world, the vast majority of those sites are getting pretty long in the tooth age-wise, and their ability to maintain 100 and 200 kilowatt rack loads, not to speak of 500 and 1,000 kilowatt rack loads, is predominantly the impetus behind why these massive sites are being born right now, is because they have to be built special purpose. And so, lead people through what is the, I maybe most of our data center listeners probably have an understanding it, but what percentage of the GPU is being solved by the air side, the water side, the door side, the directed chip side? Give us a lay down of what a typical hyperscaler GPU rack is looking like.
Yeah, sure. Well, so it's important to remember that the servers that go inside those racks, they consist of motherboards that essentially are the framework that a lot of the peripherals are all installed. So you have things like power supplies, you have the chips, which can be, CPUs, GPUs, TPUs. They go by many different names.
Yep.
And then you have all the other elements, so things like RAM and DRAM. So there's a lot of other pieces, parts that go into the fabrication of a server,
Yep.
Or a router or what have you. And so each of those has a different load profile associated with it. And so back when we were just dealing with lower density CPUs, all of that got air cooled. So you would have, more than 100 temperature sensors on all those little pieces, parts on that motherboard. And there would be dedicated, platform engineers at each of the companies that would engineer some software that would help load manage all of that. So keeping the CPU from overheating. Let's say if the entering temperature coming into the rack got too warm,
right?
Well, they'd speed up the fans to blow more air through there. And if that still wasn't enough, well, okay, maybe we have to throttle the CPU on there and not overclock it anymore, as it were. So basically now with GPUs, they're too hot to remove the heat with air. So we had to get a different form of heat transfer into the fold in order to really make this work. But that doesn't mean we have to make everything on the board be this new liquid cooling.
Right.
And so they put a little heat exchanger on there, just like we would have with a CPU, except that was a heat exchanger to just take the heat to the air. Now we're taking the heat to a different form of liquid. So it can be just 100% water. It could be a polypropylene glycol and water mix. It could be a refrigerant. It could be single phase or two phase.
Right.
So it's just another way of taking heat off of a really high density piece. So generally what we see on today's servers is we've referred to it as the capture ratio. What's the percent that's going into the liquid cooled system versus going into the air cooled system? And so typically, again, it varies depending on vendor, depending on the density. It does not scale linearly. But we see about an 80-20 mix for a lot of the platforms that are out there right now, meaning 80% is going into the liquid side and 20% still going to the air side. Yeah. So to make that in concrete terms here real quick for the viewers, if I have a 100 kilowatt rack and I got an 80-20 split, that means that 20% of that is 20 kilowatts a rack now in air cooling. And just, again, to baseline things, that's larger than a lot of our cloud compute sites on average today, right? So they range typically between 10 and 20 kilowatt a rack air cooled in a lot of the cloud sites. So we're like either higher or up on the upper end of a lot of the cloud sites today when we start deploying 100 kilowatt racks. And that's just, it's a huge step change just for the air-cooled side of the world.
Right.
Where everybody put their head around, like, wow, in a lot of sites, we're going to double the air-cooled density. And, oh, by the way, we've added 80 kilowatts of liquid cooling on top of that.
On top of it.
And that's just a 100 kilowatt rack. And we're already way past that now.
and so do you agree? And so the early ones were the likes of water, right? And there was a lot of misses, a lot of near misses, and a few successes along the way, and which led, remember at the time we had this whole cryptocurrency immersion tank trend that was happening, and that really never took off ever in the IT world, or it wasn't near as popular. But at the same time, the refrigerant-based guys, whether it was single phase or two phase, came out. I don't see any way, and I'd love your opinion on this, I don't see any way that the two-phase refrigerant approach to direct-to-chip cooling can't be the ultimate winner here for being able to do that. But maybe you have a different opinion. What do you think about that?
Yeah, sure. So we got a lot of topics in the fold there. So when we look at you got to remember the occupant of a data center is not what most people think it is. It is the software first and foremost. So the entire business model, performa, et cetera, that we build these facilities and these servers around is actually architected around the software. And
Right.
and not all software is alike. So in the crypto world, they're using a very application specific type of software, and their form factor, the yields, as it were, that they're getting out of like an investment on a per square foot. So you think of like the real estate guys, they think everything in 2D, they think real estate.
Yep.
What's the cost per square foot of this building? What's the cost per acre, et cetera? And so their financial models and how they get capital and pull down debt and all that kind of stuff is all wrapped around like what's going to be the return on the software that I have in this facility. Well, when you get to crypto, it's a bit different, right? So they were able to deviate from the normal form factor, right? So how many racks you have in there over a certain square foot and what kind of density could you get with that? Versus what they're trying to do in the crypto world. And I'm greatly simplifying it here, but it's a different business model and a different financial model. So they're able to change the form factor and change subsequently the cooling media to make that work. Yes. And it made sense. And you go to crypto mining facilities and tons of them have immersion applications. So when we get back over to today's cloud and AI compute side of the coin, I do think that there is a roadmap where refrigerants are going to play a heavier role. And there are several industry reports out there that already talk about this and have kind of their own forecast view of what percent of the market's going to be refrigerant-based in 2030 versus immersion versus liquid cooled with some form of water versus air cooled, right?
Right.
But I think ultimately, there's a lot of pros and cons that come with the refrigerant. We're going through a major change in refrigerants right now globally because of the global warming potential and regulations surrounding all of that. These things are all kind of converging to make it, I'll say, challenging to solve for all the technical aspects that you have to when you're using a refrigerant-based approach, especially when you're doing a phase change.
Yeah.
It's even more complicated. You're adding more degrees of freedom to the problem. I think there's still a lot of detail to be worked out there. There are some pilot applications. There are some vendors with solutions on the single phase side of refrigerants, basically doing pumped applications as opposed to compressorized. I do think as we look at things like megawatt racks, we have to get to a phase change. Yeah. We're outgrowing the capabilities of water, and frankly, it becomes really risky. Your tolerance to the temperature swings that can happen and how do you maintain that? I talk a lot about this in the industry where we're trying to make the mechanical systems move at the speed of light, like our electrical counterparts. And it's really hard.
Yeah. Yeah. The adoption time for them is just not there, which brings up a good point about GPUs for those who don't know, right? We've all heard the stories that a GPU uses its energy in pulses or its compute in pulses, which is just wreaking havoc in the electrical mechanical systems and the ability to do it. And that the consumption or the average utilization of a GPU is somewhere in that 40% range, which means that we're oversizing our facilities in order to accommodate a peak load or beyond a peak load, in order to accommodate a much lower steady state load. Is that actually what's being confronted by most of the AI developers right now?
Yeah, so a few interesting things have emerged. One is, with AI applications, it's true that they tend to overclock the processors, and they tend to have like high swings in the load profile on them. And I'll bifurcate it, and I'll say essentially a couple of different camps. One is the high frequency pulses that they have on those particular chips. And what they found is that even though they do overclocking of those, to say all the way up to 150%, when you look at the average of that waveform, the electrical systems, like let's say it at the UPSs and the generators, et cetera, it averages out at 100% load profile. So that electrically, nameplate, ratings, all of that stuff, they're able to still make all of that work despite the high frequency pulses. Okay, so park that aside for a second, because I think a lot of the electrical guys that are listening to this are going to be like, yeah, we got that part figured out. What still hasn't been figured out really well is on the software block loading, I'll call it. And software block loading can be, if you think, just take your average search engine, or like take a navigation app, right? So at rush hour,
Yep.
the navigation apps are getting hit hard by millions and millions of people, whereas they're probably not at 2 p.m.
Right.
And so AI applications have very much similar things that go on with them. And we're talking on the inference side. On the large language models, they can fluctuate with very different load profiles, where they go all or nothing, or they go all and then maybe a 80% throttle and then all again, or maybe down to a 40 or 50% throttle and then all again. Each of those brings about a new type of problem that we have to solve for when we look at the infrastructure and when we look at the grid interconnect. And I think the beauty of software is that it can change a lot quicker than we can change out generators or UPSs or HVAC or chiller units on a data center. And so I think what we're going to find is that the software guys are going to solve for these large load fluctuations that they had originally planned for. They're going to learn that you can't do a whole bunch of those, and you certainly can't do them back to back, because my mechanical systems cannot respond timely enough to meet that demand. If you drop it off a whole bunch and then swing it right back on, that mechanical does not come on like a light switch.
Right.
And there are ways to design some resiliency in to deal with that, like thermal energy storage and a host of other control strategies. But that said, there's only so much we can do, and there's only so often we can do it. So we kind of have to limit it. Like for utility outages, that's one of those cases where there's no control over it. And even though we have backup generators, we have open transitions on the electrical systems. And so we do have blips of power on our chillers, and then we got to restart them, and that takes time, blah, blah, blah. So I think what the market is finding is that, yes, AI software load profiles matter. Some of it was a scare, but it turned out to be readily addressable. And the equipment manufacturers have already stepped in and done most of that. There's another piece that's standing out there that is a big what if, big question in everyone's mind. We know a lot of the software is designed to have these big swings. Can we handle them? How many can we handle? And how real are they? And is the industry willing to rewrite the software so that we don't see those? Or we make them more gradual to where a mechanical system can respond. It's not going to be a problem. I think the software guys are going to figure it out.
Yeah, that makes sense. And there's a lot of areas that we can go here, but I'm just going to throw out a few, and let's see where you want to talk about. So first of all, what the many listeners might not realize is that we are both members at Abundance 360, Peter Diamandis' group, and we spend a lot of time being the quote unquote data center experts in that group, which is very AI centric and very longevity centric as well. And that's where, it really became interesting that we met Dr. Gil Verdon from Xtropic, who was taking a look at the potential, the other TPU, I like to say, not the Google TPU, but his thermodynamic processing unit. And, as being maybe before we see quantum, right? In fact, definitely before we see quantum, at least be commercially viable, right? Which is your holy grail non-deterministic chipset. We'll likely see a different workload in the TPU or a thermodynamic processing unit, perhaps make its entry into the market. I know he's working feverishly right now trying to get that out there to be one of the others. So that's one impact that I think that we're going to see. And these innovations are happening so fast. It's unbelievable.
Yes.
That's one. I know that our listeners probably also want to hear a commentary about, we keep reading that we're building more data centers at a faster clip than ever before, and that the grid is being taxed. And that we're reading more and more companies talking about their transition to nuclear. But having come from a military defense contractor background, pardon me, coming from a defense contractor background, I still think that we're at least 5 years away before we vet the technology of a Gen 4 reactor, and maybe 10 years away before a Gen 4 reactor is even commonly practiced in there. What is your opinion on that whole nuclear game that's happening out there right now?
Sure. I'll hit on both of those topics because they're great topics. So
Yeah.
there's definitely a need to reduce the energy consumption and the demand of a lot of the data centers we're building. And I think Gil's pursuit of a new chip and a new form factor there is one of the answers to that problem. I don't see that as a replacement to existing chips, but definitely supplement to it. Much like a lot of the servers nowadays, you have both CPUs and GPUs coexisting. I think we'll see the same thing. If his chip successfully gets to market, I think you'll see that integrated with a combination of CPUs and GPUs on a motherboard. I think they serve distinct compute capabilities and they help enhance the capabilities of some of the others. And really then it's a software problem. So how do we leverage these three different chips that each are really good at a different type of computation to form this new type of compute that can do way more processing at way less energy, total energy on a per compute basis? I think that's definitely going to come about. How quickly that all happens, your guess is as good as mine, but and it needs to happen. We desperately need something to offset some of the demand with GPUs in the mix. Nothing against NVIDIA, but we got to come up with some other answers. On the supply side, I think we have a host of things working in our favor now. And I personally worry much less about the power problem now than I think most people are still talking about in the industry conferences. And that's for a host of reasons. One is when we look at the natural gas play, we have a really incredible position here, at least in the US and arguably elsewhere in the world. They'll have something similar where we have a lot of natural gas resource now.
Yeah.
And the technology is such that it has unlocked a lot of natural gas resource out of the Earth's crust. And we have a lot of big companies that are interested in furthering the investments in the power plants to use that gas. Yeah. So new entrants like BP and Exxon and Chevron, right? Those guys, the oil and gas guys, are now coming into the data center space and saying, hey, we can support this. This is game on, man. And I think that's going to be huge. I think there's going to be a lot of those deployments between, take Texas and Pennsylvania, for example, where we have a lot of the infrastructure and the pipelines, two richest natural gas states in the country, but a host of others out there as well. I think they're going to do large plants, not only for the utilities, but for the data center operators, perhaps behind the meter, perhaps islanded applications that are going to solve, I'll call it the 5-year window here, or let's call it 5 to 10. Lots of new big turbine manufacturing being turned up by the likes of the Siemens and the GEs and Solars of the world. So I think there's enough of the supply chain and enough of the big money of these other companies that see the opportunity here. They're all leaning into the pitch. They're going to close that gap on the gas side. And, you heard the announcement. We're extending the life of a whole bunch of coal-fired power plants. Nobody wants to hear that, of course, other than those that are in that industry.
Right.
There's like 86 units we were going to retire in the country that we're now going to extend another 5 years or what have you to help solve for this power shortage. Which, by the way, is good for the ratepayers because that's the cheapest form of generation. So it's going to keep the cost down. So anybody that says, hey, I want to get rid of them tomorrow, well, it comes at a cost, right?
Yep, absolutely.
Nuclear, I think, is quicker on the heels than what you described. There was already some legislation passed last year in Congress that was kind of quietly hidden from the rest of the public, but it's good. It's removing some of the hurdles to get some of the SMRs or small modular reactors deployed, which, by the way, are all over on our submarines and our aircraft carriers roaming all over the seas in the globe and have been for many decades. In fact, we've got north of 50 former Navy nukes on staff now in our company that help with a host of our field services and former operators of those plants. So, they'd be comfortable going back to that tomorrow if we needed to, just on a terrestrial basis. So I do think we're seeing, between the money flows, the companies that are being set up, the regulation that's being cleared, the land that's being allocated, be it federal lands or otherwise, for the deployment of those, we see a clear path at this point, starting within 5 years, actual deployments, actually grid interconnected. You're hearing the contracts announced left and right at this
Yeah,
point by some of the hyperscalers. There's a lot more that's not being announced, to where this is a lot further along. I'll say it in the
that's great
ecosystem,
news.
and everybody sees that it's going to be a net ad. It's going to be a valuable thing to do. France is way ahead of us, right?
Yeah.
They've known this for a long time, blazing the trail. I think it's about time we caught up with that race.
Yeah. Traditionally, the nuclear was one of the more expensive approaches on the that scale of cost to benefit up there. Do you think that continues in the SMR? Still will have the premium price tag for the amount of concrete and steel that is required for a unit of power versus, let's say, on the opposite end of that, the gas turbine industry is probably on the lowest cost of that scale. And do
Yeah.
you think the two will level out at some point, or do you think there's always going to be that economic advantage of the gas guys have over the nukes guys?
So I do think there's a lot of leveling that happens. I think we're already seeing sub 10 cents a kilowatt hour on the nuclear front for the SMR deployments, at least the contracts that are already being talked about in the marketplace today, which is very encouraging, right? If we could stay sub 10 cents a kilowatt hour, it's going to be nuclear all day long. But you can also be there with natural gas at sub 10 cents a kilowatt hour.
Yep.
I think there's room for all of it to play, as
Agreed.
we've already seen over the past 2 decades, where we weren't really adding any new net generation to the grid, but we were swapping a lot of the coal-fired for solar and for wind and for hydro. And we were offsetting all of those decommissioned coal-fired power plants. Well, guess what? All of those made economic sense, or we wouldn't still be deploying them. And yes, there are subsidies that have to be in place for some of these as they're just entering a market. But then you get economies of scale, pricing comes down, and everything levels itself out. You have to remember, though, with the power grid, it's also interesting, and why I say it'll all be in play. We have this peak market, spot market in deregulated portions of the grid throughout the U.S., and there's money to be made there. So there are entire plants that are stood up to be nothing other than a peaker plant, where it's just handling load shedding in the hottest days of the year, and they're able to pay for those investments in very short order just through those minor amounts of operation. They're not base load operations. So I think if you can do the gas there, you can definitely do the gas on a baseload basis. And I think if nuclear is coming below 10 cents a kilowatt hour, everything's going to be in play. Everybody's going to make money on it. We'll keep the ratepayers from having to overpay for their power as generator expansion, continues, and it'll all equalize, and the capital markets will do what they do, right? Supply and demand.
Yeah, while I was on vacation recently, I took the opportunity to read Václav Smil's books, and he's the guy who wrote How the World Really Works, and then his more recent one was Innovation and Invention. And his if you're not familiar, his position is basically that the world has been governed by the production of fertilizers, ammonia, right, steel, concrete, and fossil fuel energies. And his argument is that everything is fed off fossil fuel energies. But I tend to agree with you that we're going to have an opportunistic power approach to how we power all of these facilities. And it's going to be a combination of gasification plus nuclear plus, traditional electric plus alternatives, which, have their own bevy of problems. And so, look, here's where we've covered. We've covered that there's, we have the chip answers. We know how to cool them. We have future chips in the pipeline all the way down to quantum and here. So we're going to be doing the software and the compute side, okay? And really, we probably are not going to have a power problem we're going to have in there. The one thing we haven't talked about yet is what is the data center industry going to look like? Because right now, the predominant workload in the pre-robot world, let's call it, is this modeling, right? That's who's right now. We're just training lots of models and the inferencing that goes along with it. But right now, a lot of the inferencing is human inferencing, right? And so, my position on this is that in a very short order of time, the predominant workload is not going to be modeling anymore. It is going to be predominantly inferencing. And so, without leading the witness too much, what do you think that means for the data center industry as inferencing, probably non-human inferencing, machine-based inferencing, becomes the predominant workload faced by the data center industry?
Yeah, I think we're already seeing both being deployed at large scales. It's just not being talked about a lot.
Right.
A lot of we generally know when we're doing a large language model site, they are designed different than an inference site. Even though both have liquid cooled infrastructure, they are designed different.
Yeah.
So when I look at the total percent of like sites that we're working on that are that unique large language model or small language model or some other version of a language model application versus the other types of sites, there's more of the other that we're doing right now. So that's to suggest that we either already have pivoted and we know that we're going to be doing way more to inferencing, to your point. So without leading the witness, I would say that just with my own observation, we're already headed down that path. I agree with you. I think there's way more to be done there.
Yeah.
It's not to say that there's not way more to happen on the large language model side or that there's new creative things that are happening over there as well. I think we see both of them continue to explode. There's the creation of synthetic data now because basically we've gone beyond all human knowledge that's been created. Once we start deploying more drones and humanoids, and we have more of those out there with more sensors able to gather new insights and new data that's above and beyond what people are currently doing, I think the equation of what can be done on the large language model site is going to significantly change. And I also think we're at the very beginning of the exploration of synthetic data development and lessons out of all of that. So I think that science has a long ramp to go. Way beyond what any of us can comprehend right now. On the inference side, I think the part that we're not seeing yet, so we're still seeing, I'll call it the cloud scale type of builds for liquid cooling. There's a lot of new stuff, obviously, and there's a little bit of retrofit. To your comment earlier, there's some retrofit, right? So it's selective though, where they can get the power because it's really not. It's not about retrofitting for the mechanical. That's as much the problem as it is. How do I get? If I'm going to do it, how am I going to get more power? So
you're in my sweet spot right now. That's what we're doing a lot of.
So it's where do we go to get more power? And if we can get it for that particular site, all right, let's look at it as a liquid cooled site and let's consider retrofit when the next lease comes up. So I think the next new realm, and you and I have talked about this, is the smaller inference applications, the sprawl of inference, right, as it were.
Yeah.
And I think we already have a version of that. It's called the telecoms. And we've both worked in it, around it for a long time. So, you think of everything from like cell sites and pop sites and mobile switching centers and all of those different points of presence to get combinations of fiber and cellular phones and microwave and all those pieces, parts, including satellite, out to the broad audience. Those already represent essentially a remote or sprawled inference application. I think we see way more of it. A simple use case is just the fraud prevention aspect. So you think about credit cards, you got to head off the fraud at the point of use or the point of sale, as it were. So as keystrokes are hitting a device, is this a fraudulent activity? Well, in order to do that, we still are up against the speed of light. So you got to have more facilities closer to those endpoints. Or where are those endpoints? I don't know, wherever people go, wherever the robots go, you got to be close to them.
That's right.
And how close? Well, within 150 miles, roughly, based on speed of light. So you got to have one of those pretty much everywhere if you want to be able to pick that up because speed of light's just too slow.
Yeah. And as you know, in the shameless plug of it all, that's exactly what my belief was with the evolution of Gray Wolf data centers. We're starting in Connecticut. We're, close to financing it and finding the right clients for them. We're using both off-grid and, on-grid and off-grid solutions in there. I mean, our two groups talk a lot. That might surprise people to know just how much we actually work together, even though we both cumulatively, own different firms that I'm purely design build entity, but I want to focus on the smaller sites. By smaller, smaller used to mean, a few megawatts. And today, smaller means 20 megawatts and below. And, because these
Yes.
sites are getting megalithically huge.
Yes. That's
And
right.
so, yeah, but Gray Wolf's data center is, we're building something for what the future will be. I do have a question as to what do you think the role of like say the core weave approach, which is that I'm not just building sites anymore. I'm actually going to build them special purpose as data center as a service, almost GPU as a service. Do you see that being a big part of the data center industry moving forward, or do you think the cloud guys and the other models will
Yeah,
perpetuate?
yeah, it's interesting. There's been a lot of debate over that, and of course, when they recently announced their acquisition of Core Scientific, that got the market thinking, "Oh, okay, maybe this isn't just about a GPU as a service anymore." I think the challenge with any of the new technologies is, the price gets driven down as a function of time and as a
Yep.
function of saturation of the market, and so you have to go into it knowing that is one part. So it's how do we monetize this asset that is constantly depreciating in value. So that's the one challenge. The other part, back to my comment about the software is the occupant. Well, the software has also been the foundation for how the data center market has monetized itself. And whether it was selling advertising on top of that software, because that software generated lots of data that was useful to connect customers versus buyers, buyers with sellers, I should say. I think ultimately the GPU as a service model, it was probably a good short-term play. I have a hard time wrapping my head around the economics on that over a long term. I
Agreed.
think converting a portion of it to a fixed asset that you can get, 15-year lease deals on, that aligns better with, they'll call it the long-term capital markets. And that's really the trick here. And I did a post on this recently on LinkedIn where, I just identified that we have a mismatch between how capital markets go about, raising debt, financing projects, and the long-term view that they have, and how AI is like compressing all of that.
Yeah.
And that misalignment is going to result in some lulls, I'll call it, of the growth of the industry, right? You can only grow so fast because there's only so much money to pump in. And then it's like, wait, we got a mismatch between our investments and the durations and the returns. We got to take a breather. Okay, now go again,
Yeah.
right? And I think what, this is just me talking out loud, speculating, but I think what we're seeing with the CoreWeave, Core Scientific, and, just since you highlighted them, is I think we're seeing that tug of war in real time. And we're seeing like what money's saying it needs to do for a return versus what the businesses want to do and how they see both the software and the hardware being capitalized.
Yeah.
I think we're going to continue to see examples of that tug of war play out for the next 10 years.
I agree. I think it's like the power and the cooling, right? We're going to see all things persist with no real clear religion anymore as to the way, because all of them are going to serve a purpose, right? Just like every chipset from quantum to CPUs. Heck, CPUs are going to see a resurgence in the inferencing world. They actually do it better, or in some respects. And so we're going to see a lot of CPUs back on there. So I think we're going to see all things flourish. Which leaves us in an interesting place, you and I, because we lead organizations that are in, the right industry at the right time in history, and we almost got to just not get in the way, right? And we're learning from the same altars, let's say, right now as to where we're going, and to the point you made me think about in the software, it was an interesting perspective that it's all software led. If the opposite of Extropic, the guy who's going to do the hardware is going to be a guy like Jay Dewani's company, Lemurian Labs, to which, full disclosure, I'm an investor in. But I like his play because his argument is that all of these chipsets are going to persist at one time, which is going to make it difficult for the guy who builds any one chipset to also be the underlying software. And here he is saying, nope, I'm going to develop a full stack software that is going to treat every chip set heterogeneously and allow me to operate, across an entire chipset. Of course, he hasn't convinced Gil yet to do that for the TPUs, but he'll do it for every other one, and eventually he'll probably cave too. That's purely my speculation, by the way.
Yeah.
But it's going to be interesting to see how he plays out as well as being the software vendor to all the chipsets, because I don't think we're seeing the end of that game as well. I mean, hey, traditionally AMD is a superior manufacturer as far as chipsets. It's been their software that's been their limitation. I find it interesting that they're one of the largest investors in Lemurian Labs, because I think they know that being that autonomous software might be the key. What's your thought about that?
I think to your earlier point, I think there's an unbelievable playground to play in at this point in time. And that there's a combination of a lot of rapid change happening that has opened up all sorts of new gaps between the supply and demand in the market. There's no question. If you get all these different components in the mix, including multiple different types of chips, the manufacturers have already had to work together to figure out how to solve that problem. CPU to GPU as an example. When you add 2 or 3 more versions into the fold, it'll be the same thing all over again. Is there a play to do some open source version of making that work? Probably, right?
Yep.
Is there a version where somebody's come out with a proprietary platform to do it? Probably. Will both of those run in parallel? Probably. Much like what we're seeing right now with, Open Compute Project as an example. They're a version of that. And while some of the companies have signed up to that version, there's others that are on their own proprietary path. I think we will see combinations of all those out in the market. And the beauty is it's big enough to where I think everybody wins. It's not going to matter. And as I said in another LinkedIn post, because I tend to put my thought-provoking stuff out there in this manner, never in history have we stopped the pursuit of more knowledge and more intelligence. And AI just represents now an accelerant to that. And I think there's no end to it, right? There never has been.
Yeah.
And so that's why I say when people are like, well, don't you think this is a bubble? Or do you think it's going to, stop at some point? My answer is no. Do I think it takes some lulls and some breaks, some plateaus because we got misalignment in certain pieces in the supply chain or the way money is financed? Probably.
Yeah.
But is it gonna burst, or is it gonna we're not gonna do it anymore? No, that's not gonna happen. We're just gonna continue up. It's just how quick is that trajectory up?
I agree. And it's been at a rampant pace, and I don't see it slowing down anytime soon. I do think AI, it's the most fundamental technology that will ever impact, mankind. And it's only at its infancy for as old as it is, but it's only at its infancy, which brings me to it's trendy. Just to change gears for the last few minutes.
Sure.
When it changes humanity, I forgot my point I was going to say. It had to do with where we as a species evolve, in this AI age. And as business leaders, you post a lot like I do. It's very different than, 20 years ago of what I did as a business leader. And it's funny, the guy that I've been following a lot has been Gary Vaynerchuk, right? He's a 50-year-old guy, Gary V, and he's got this whole personal brand. And he talks about that the best thing you could do for your company right now is to build a personal brand around your identity. And so you could see everything. This is all built as PeteSacco.com, because right now, everything I do is to build. My life experience is such that I've been exposed to so much in the AI and where it's going and how it's going to impact humanity, that I believe that we are going to be a world full of independent innovators. And you and I are going to hire these independents to potentially work for us, an independent contractor. And you're ahead of the game in that you're a 400 or 500 person consultancy that's been remote for 5 years now. How long have you been remote?
Yeah, since day one of the 2020 shutdown.
2020 shutdown, right? And you've made it, I arguably made it work as well as anybody has against the fray. I mean, you're hearing articles all the time about people saying, no, we got to put everybody back together again. But, you've proven that you could do something as interesting and as cutting edge and as creative as your business and have this. I think that only builds. I think that's where I was going with this, is to say that humanity is about to be a whole bunch of independent contractors. And the guy that's going to be rewarded is going to be the guy who plays in the new game of, it's no longer going to be your individual knowledge and skills that are rewarded, but your individual innovation that you can IP protect, that you could build an audience for. And I applaud you because you're doing a lot of that out on social media and representing, your brand well. And I know I'm doing that for me, as well. But you're just comments going out as to where do you think the world go? How does humanity get impacted by this and the pace of play that we're in?
Yeah, boy, we're going to need a whole nother episode for this at some
I
point.
hear you, brother.
And probably a few other things in order.
I think that's a good one. That's for the book, right? The book came. Where am I? Over that shoulder. The book came out, Living in Bliss, and that's it. I'm this weird guy of 58 years old with the young family and and the old family. But at the intersection of AI, but I'm as confident as I've ever been about where the world is going. But realizing this has always been an inward journey. I would love to explore that with you separately. We'll put that one on Bliss Mode, because that's the other podcast that I talk about, mind, body balance and spirituality and all of that. So nice. I'd love to have you on there too.
Right now, I would say just in closing, my outlook on AI is positive, which is counter the way I normally think about things, because I think about the risk first. And the reason being, it's too easy to think about the downsides with AI. Been there, done that, plenty published on it. I think really the challenge for leaders like us is, let's create the future that we want rather than that. And we have to put our time and energy toward that at this point. It is a harder problem to solve, frankly, because again, it's easy to go to the negative path with it. I think as far as I see it right now, there has to be a lot of integration. There already is. Everybody's walking around with a smartphone constantly. That is a form of digital integration already, human digital integration. I think it goes steps further. I think we can do it toward the positive. And I think the foreseeable future, as it relates to data centers and what you and I do, sky's the limit. And I'm looking forward to more.
Yeah. There is no, I agree. There is no limit. I like to tell people, in fact, it's the TEDx talk that I'm going to be doing. It's about, let's stop looking at AI as the rival, right? Let it do the mechanical, let it do the machine things, right? AI is going to allow humans to do what they do, and that's be more human. And so luckily, that's the world that we're going to go. I'm the supreme optimist in that. But Dave, look, I enjoy talking to you every time we're together, right? And so I really appreciate you helping me put this out there, for being as candid as you were. And so thanks very much. And is there any last word you want to give anybody, or we're good?
No, I think thank you again. I'm honored to be your first host.
Yeah, first guest. Yep,
first
absolutely.
Guest on here. So thank you again, Pete.
Yeah, thanks, Dave. We'll get together real soon, I'm sure.
You got it.
Thank you for joining me on the Pete Sacco Podcast. If today's conversation sparked insight or inspiration, don't forget to subscribe, share, and leave a review. You can find more on YouTube, Spotify, Apple Podcasts, and LinkedIn. Until next time, keep evolving, keep leading, and find your bliss.